Hello.
Oh, can you hear me?
Yeah, I think that I
Is
yeah,
everyone available, and can you all hear me? Please confirm.
just less than a minute. I think we can start. Uh, just give us 1 minute, and I think all will be here. Here with us, Engineer Ahmed from the sales team, as well as Engineer Rana. She is also on the technical support and sales team. Will join us now Engineer Hussein and Engineer Saaz. Engineer Saaz is a CEO, and Engineer Hussein is a project manager here. Okay. Can I ask
Okay,
you
I'm waiting
just
for you.
I think it will be 1 minute, no more. But if I can use this minute to ask you, what if we can arrange another general concluding training within 1 hour as a maximum to be as a sales training for the overall product range of your portfolio. This is some sort of sales training, not deep technical, and I think it will be capable within 1 hour. But we can arrange it last end of this week or next week, inshallah. That's possible.
Sorry, but I don't understand exactly. I think today we will make a small training. I will explain you about HFC systems, and we can decide ongoing requests after this meeting, okay?
Okay.
Okay.
Just clarifying that today I know that it's for FM 200 HFC, but I
Yes.
mean if we can furtherly or later plan a general overview sales training, not technical depth. One for the sales team here, overviewing all of your portfolio. We are talking about FireSearch, which is Firelords, Safe 227, and Safe Novik system, as well as CryoBlue.
Yes, sure. We can make another meeting as we talked with you on WhatsApp. This is what I'm also explaining. So let's use the time for today as we planned for Safe 227. I will actually, regarding the technical requests that you ask for me, we have a very basic configuration that we can provide you just to give an insight for your projects, because actually designing and deciding on the system criteria as a final product is requiring a very technical skill and time. So it's not possible for me or for anyone to just explain this and give a training in 1 hour. But
Yeah.
because of your request, I try to prepare an Excel sheet for your team. So whenever you receive an inquiry from your customer regarding an HFC system, you can always go through our configurator Excel, and you can try to manage a system capacity and try to determine the system capacity and the product itself, so that you can ask for the quotation from us easily if this is what you request. So today I will try to explain you how our customized configurator works, so you
Good.
can use it. And also I will try to explain you our Safe 227 product range. If you can work on it, or if you can look on our technical catalog regarding the product portfolio, product range, you will be easily determining the system capacities. So I'm waiting for your team to gather all together, and then I can start. Okay.
Okay. Just last question before starting. Is there an update about the Firelord datasheet and crash test?
Yes, Azat, the fact is we have decided to renew all our Firelords product group technical data sheets and technical documents. That's why it took so long, because all the valves and the cylinders have been drawing in the SolidWorks and they were turning into the data sheets. We were in a sort of a renewal procedure. I thought it would be much more fast, but I think this week it will be finished. Today, Ünal and our technical team were working on it to finalize. They are going to finalize your requested product group first, so they will hand in the technical data sheets to you, and then we will keep on renewing our other product data sheets as well. So I hope this week it will be sent to you. I think also you now might have a little touch on the price list that I gave you. So actually he's following up, and I will support you whenever he hands the documents into me. Okay.
Good. Thank you so much. I'm not pushing, just checking with you the update.
Yes,
okay,
yes.
I think
I'm really sorry, because I promised to you, but unfortunately it took longer than I expected. That's why I'm a little bit nervous, and I feel sorry for you. Sorry.
No, I'm sure that these processes takes a lot of time, so it's okay. Do you need any support regarding SolidWorks? Just laughing, nothing. Okay, I think we can start now.
Is everybody here that you expect?
I sent them, and they can join us. So we don't have to wait to wait more than that. We can start, and I think it's recorded, and they will catch up with us.
Okay, no problem. I arrange my time for you. If you like, we can wait a little bit more. There is no issue for me.
Just a couple of minutes.
Going to visit Interschutz exhibition in June.
Which fire
in Germany, we have an Interschutz exhibition. We will be exhibiting in June in Germany. I can send you an invitation about this.
Pretty good. That's good. Yeah, I think we have waited a lot, so we can start now. They will catch up with us, I'm sure about that. Maybe they have some discussions, so we can start. You can start now. Also, the main
sure.
dedicated persons are here.
Okay, sure, no problem. So I can start. First of all, hi everyone. I hope you are all fine. And I hope you all hear me. If you don't hear me, please make a sign so I can check myself. I will start, and I think last week I sent the technical catalog to Mr. Ezzat, and he would send the technical catalog to you so we can go through during our meeting. I'm going to share my screen now just to show you which catalog I'm talking about. Please confirm if you can see my screen.
Yes.
Okay. So, Ezzat, I think your team can hear me, so I will continue. Is that correct?
Yeah, I think it's well. I think it's very clear. Ahmed, it's working at your side, yeah.
Yeah, I can see clearly.
Okay, great. So this is the technical catalog that I sent you. I hope you received it. And if you had a chance to look at it, it would be fine. Otherwise, no problem. I will lead you how to check. So this is our SAFE 227 system technical catalog. Actually, one of the technical catalogs with a certain product line, but this is the product line that we are going to work with you. We have our system approval with VDS, basically. So in case if you want to deliver the systems with the system approval, we will be able to supply you a VDS system approval. Otherwise, we also have the same product line with UL approved components. However, in UL case, we didn't receive our UL certificate yet. We will work on it. So we are not UL approved, UL system approved, but we have the valves and the actuators and the cylinders with UL approval. So we can deliver components approved products as well. But today we are talking about VDS system approved products line. So we have two different system approvals. One of them is working under 42 bars. The other one is 50 bars. And we are working with high pressure seamless steel gas cylinders. It means our cylinders are not welded and we are not working in 25 bars working pressure. We are working in high system working pressure. So if you can follow up the technical catalog, you are going to find our system components here. And you will if you go a little bit lower on the 6th page, you will always find our cylinder range here. Our cylinder range is starting from 14 liters up to 180 liters. So we have a pretty good and high range of cylinders. 14, 27, 30, 50, 75, 80, 120, 140 and 180 liter cylinders. Here you can find the cylinder capacities as well. You can find the cylinder heights and the cylinder diameters here. We have different configurations with these cylinders. So as you can see, 14 and 27 liter cylinders are our little cylinders, smallest system capacity. And with this smallest system capacity, we designed two different product line. One of them has the valve, the system valve, with the electromagnetic actuator integrated, and one of them doesn't integrate the electromagnetic actuator. So this creates an easy selection between two systems. I will explain on the bottom. But apart from 14 and 27 liter small size cylinders, we have basically two different size of product groups. One of them is starting from 27 liter until 120 liter, which has, here you can see the valve outlet connection. This product group valve has DN33 product valve connection, and here from 120 liter until 180 liter we have DN50 valve connection. So basically these two different product groups are referring to different hazard capacities. Okay, so in this page you can see the stock codes, the article codes of the cylinders with 42 bars system pressure, and we have the same product line for 50 bars of system pressure here, same cylinders and same mentality I explained to you. But if you want to check together with the article codes and the system codes, you can always check from here. If you would go through the technical catalog, you will always have the information about the extinguishing agent, but I'm sure you are really you really know about HFC 227EA cleaning agent. If you have any questions, we can talk later on as well. Here we have a table, a chart, which is indicating how much kilograms of gas we can fill the cylinder, minimum and maximum actually. This might lead you a little bit more on the technical design. However, I will explain you in detail with the configurator, but this can give you an idea. Actually, for example, let's say for a 50 liter cylinder, you can fill 50 liter cylinder, or on the lowest, you can use 20 kilograms of HFC 227EA, but at most 60 kilograms of HFC 227EA. I find these quantities, the minimum quantities very minimum and the maximum quantities very high. So this is not a safe zone to use. Instead, I would recommend you to always try to design the filling ratio around 80 to 90%, because I'm sure you also have a similar problem. When we are preparing a quotation, we don't deliver the architectural design of the hazard, and we don't know where exactly to locate the cylinder and how the pipeline will be. So we need to stay on the safe side, first trying to quotate for the system capacity. So I would never recommend to fill a cylinder even 100% or more. This table is more working if you know about the architectural design of the building, if you know more about how to locate the cylinder, and if the hazard is really easy to install an easy pipeline. Otherwise, it would be better to stay on 80% of filling ratio, which I'm going to explain you in the configurator part, but I hope you can also follow up. I want to check if you still can hear me and if everything is going okay. Please give a heads up for me if you're okay.
Everything is okay.
Yes.
Okay, great. Please ask me anything if you want to stop me. So on this page, you can find the agent containers and the agent container valve configurations. So as I told you before, we have actually 3 different product groups. Let's say 14 and 27 liter cylinders. Here you can always see the valve connection thread, so you can understand that these cylinders have a very particular and little valve connection. So we are using a certain valve for this product group. Here on the second part, you can see the valve codes, starting from 27 liter cylinders until 120 liter cylinders. We are using the DN33 valve connection valves. And regarding starting from 120 to 180 liter cylinders, we are using DN50 valve group. I want to explain you why we have so much cylinders in this chart. Maybe you noticed, for example, there are two 50-liter cylinders here. There is an 80-liter cylinder, but there's also 75-liter cylinder, and there are two different 120-liter cylinders. With Mr. Ezat, we also worked about this, but I will explain you. So under our system approval, we have different cylinder manufacturers. One of them is our own factory, which is CMV Cylinders Factory, a Turkish and Italian joint venture, and we are producing in our facility in Turkey. And we are actually the main supplier of many of the system producer companies like JCI, Minimax, Rotarex, etc. We are a European cylinder manufacturer facility as well on the other side. So here you can see on the second line, CMV cylinder production line, as well on this valve group. Also, you can see on the second line, the CMV cylinder production group. On the first lines, here you see 27, 50, 80, 120 liters. And here you can see 120, 140, and 180 liter cylinders. This product group belongs to one of our Chinese manufacturer, cylinder manufacturer, which we have an agreement for all our product groups as well. So because of your customs tax and your commercial concerns, we were talking about our own production line cylinders with Mr. Ezat. So that's why we have so much cylinder capacities in our product group. Here you can, on the page 11, you can find, starting with page 11, you can find our different valve groups, which we have talked about. Here you can see 14 and 27 liter agent containers, and you can see the 25E thread connection valve product group here. As we speak at the beginning, we had two different valve groups for both of the cylinders. One of them was the valve with integrated solenoid, and the other one was without the solenoid integration. So it was basically a discharge valve. I can remind you where I explained this at the beginning. Just a second. I think you remember this part. I told you that we have two groups with the same size of cylinders. One of them has the valve with integrated electric actuator, but the other one doesn't have an integrated electric actuator. So this is page 11 that you can find these two different type of valves here. This is the one with solenoid integration. This is the one without the solenoid integration, and this valve is under our VDS system approval. So here we can talk a little bit more about the configuration of this product. So in case if we use the solenoid valve integrated valve, we just need one manual actuator, and we need to decide between the pressure gauges. If we want to have a pressure gauge with contact switch, we can choose. We have the selection. We have two different contact switches, 38 bars and 45 bars. So this is for 42 bars working pressure systems. This one is for 50 bars working pressure systems. And we need to have a discharge hose to discharge the system. If we want to use this valve, basically if we are quotating for a VDS approved system with 14 or 27 liter cylinder, it means we are going to use this valve, and we need to also add a solenoid actuator, which will be here on the lower part that I will explain. So let me go to the bigger cylinders configuration. So as we talked, we have two different working pressures, 42 bars and 50 bars under our VDS conformity. We have two different valve groups. One of them has DN33, the other one has DN50 connection. Here you can find the DN33 and here you can find the DN50 connection valve. This valve is working for our 27 liters until 120 liters system capacities. And this one is working from 120 until 180 liter capacities. So they are divided into different product groups. As you can see, these valves are only discharge valves, so they don't have any integrated solenoid actuator. We are going to add solenoid actuator for our pilot cylinders. Here you can see the configurations always. This is page number 13. So as we talked before, for 114 and 27 liter cylinders, we have the discharge valve, we have the electric actuator, we have the manual actuator, or we can, for the second, third, or fourth cylinders, we can use the pneumatic actuator or manual pneumatic actuator. We can always have different selection of the pressure gauges, and this is the valve sets. So for DN33 and DN50 connection valves for the cylinders, we have the system valve and we have the manual actuator, which will be added on top, and we will have electric actuator for the first cylinder under the manifold, under the battery. This is the pilot cylinder. And regarding the second, third, fourth, and the other cylinders under the same manifold, we have the pneumatic actuator connection. So that is basically the valve connections. Regarding the second, third, fourth, or I don't know how many the other cylinders that are under the same manifold, we will use a pilot line between the pneumatic actuators of the second, third, fourth cylinders. This is going to be the pneumatic hose, which has 3 different sizes in length. This is suitable enough, actually. These longer pilot hoses will be required for different and specific situations. So basically, this is what we need to talk about at the beginning, I think. Here on page 18, you can find the detail of the pressure gauges that we talked about. So for the 42 bar systems, you can find the pressure gauge alternatives here. The scala is changing. And regarding 42 or 50 bar systems, if we need to use a switch contact, you can find the switch contacts here, normally closed. All these product lines are also VDS approved. There's a difference in case if you want to work with UL approved components, then you always need to choose a pressure gauge with the contact switch. This is the necessity of UL. So UL doesn't have this alternative, which doesn't have any switch contact. Here you can find the discharge hoses. We have talked about 3 different sizes, which is DN12, DN33, and DN50 valves. As you can see, 14 and 27 liters, 27 to 120 liters, 120 to 180 liters. So 3 different product groups are here as well. We have different manifold configurations. Mr. Ezat told me that you're not going to purchase any manifold groups from us, but you can always check from here. We have different alternatives we can use for 2-port or 3-port or 4-port of manifold groups. If we, let's say, if we need to install 8 cylinders in one hazard, then we can use 2 pieces of 4-port manifold, or we can use 4 pieces of 2-port manifolds. It depends on your design, on the architecture of the hazard, depending on the pipeline that you would easily install. You can decide, or we can support you technically. You can always find which manifold connection is going to be used for which type of cylinder groups here. Here you can also find the mounting rails for the manifolds to mount on the wall on the upper level of the valve outlet connections, but you don't have to purchase this group from us as well. We already talked about this. We have the agent container mounting rails. So of course, since we are working for high pressure gas cylinders, we always have to install the cylinders and fix them to certain walls instead of any separator or any construction that is not strong enough, because the pressure we are working with is really high. So it will become a hazardous product in case if we don't make the wall fixing correctly. Here you can find our wall mounting rails and how to configure them. So in case if we have one cylinder, this is the length of different type of mounting rails. And if the number of the cylinders are more than 1, up to 2, 3, or 4, you can see the length of the mounting rails here as well. We can explain more when we configure it. Here you can find the nozzles. We have 2 different types of nozzles under our approval. One of them is 180 degrees. The other one is 360 degrees. So this is basically the nozzle that is used in the middle of the hazard sealing, which will enable the gas distribution homogeneous in all the hazard, let's say. But in case if you require to install the pipeline on the wall, and if you need to leave the nozzle connection on the wall side, this nozzle means the wall side nozzle, so there is only 180 degrees side which has the holes, which means the gas will be discharged in one direction instead of this nozzle type. We use a lot in our lot of projects this nozzle as well. This is a really nice option that we can be more flexible about our pipeline design actually. So these will be the optional products. Here you can find the system label and explanations that are on our system label. Regarding each system capacity, the cylinders are delivered with an inner label, which is explaining the filling location and filling date and filling quantity in terms of kilograms, as well temperature and the working pressure of the system. And we have a really good fixing of our labels. So this label is never affected from water. It's waterproof. It's not easy to relocate, so it's really sticking on the cylinder, and the inside part is under protection of the label itself. We have 4 warning signs. You can use 2 of them. You can use one of them on the room door. So it's basically giving a notice that the room is protected with the system and you shouldn't go in, or you shouldn't keep the door open. There is another warning sign which should be located somewhere close to the manual actuator of the cylinder, because it's explaining how to use the manual actuator of the cylinder in case if fire detection is not working correctly or something happens. You can always manually actuate the cylinder. So we have also the cylinder room label, and we have also different warning labels regarding how to use the emergency exit. Basically, this is the technical catalog. You can go through it after our training to understand a little bit more. So we have this is a very basic Excel file that I will try to explain to you. Actually, if you prefer, after I explain this to you, maybe you can create your own design table as well, but this would give you an insight, I believe. So I think in your country, you are working with NFPA design criteria, but we are responsible for ISO EN standards as well. So we have ISO standards and NFPA in this Excel sheet. So whichever you prefer, you can use. I will use NFPA 2001 with 7% extinguishing concentration of a project. So here you can find a very basic calculation. I'm going to try to explain you from some examples. So let's say if we have a hazard, which is an IT room, and in the, I don't know, X5 building, let's say. So this room is going to have 3 meters in width and 6 meters in length. So basically it's 18 square meters, and it has 3 different heights, which is the ambient room height will be 3 meters, and we have a suspended ceiling above the ambient height, which is, let's say, 1 meter, and the raised floor is going to be 0.70. In this case, this Excel is going to calculate the cubic meter of these different volumes. So ambient room cubic meter, suspended ceiling, and raised floor. And then it's going to calculate how many kilograms of gas is required in these volumes in kilograms measurement. So it's going to use the ambient room volume, and it's going to multiply it with the design volume factor according to NFPA 7%. So now we understand that we have to use at least 46.38 kilograms of HFC 227EA. However, now we need to speak about our filling ratio that I explained you in our technical catalog. So I'm going to recommend you to work a little bit on our cylinder range, because you are going to need it to do design configuration. I go to the same cylinder table. Is everything okay? Can you follow up? Do you need me to slow down?
No, it's okay.
Okay. So you always need to go back to the cylinder range, product range, and you need to decide in which cylinder you should fill this gas quantity. So when you check the cylinder alternatives, you need to choose either 50 liter, 75 liter, or 80 liter system cylinder here. So let's choose 80 liter system cylinder to fill. Here you can find the filling ratio. So if we are going to fill 46 kilograms into 80 liter cylinder, it means that we will fill around 58% of this cylinder. So we need to make a correction here, because when we calculate the system capacity under VDS hydraulic calculation regulations, we need only 2 points after the after the separator. So it's always going to round up, and it will always try to calculate the gas quantity rounded up. So it will be not, it will not be 0.5797, it's going to be 0.58 minimum. So it means that we are going to use 47 kilograms of gas. Actually, we are going to fill 47 kilograms. This is maybe not a very big difference for this little example, but it's going to be really important for bigger hazards and more gas required hazards. So this is the important part that you need to check during your design. Here we have a separation. We have ambient room, we have suspended ceiling and raised floor separated. So we made a system capacity design here because although we have 3 different volumes included in our hazard, they were very small and they are going to be protected in one system altogether. So we just designed the system here, and we actually don't need to design any separated system for ambient, suspended, and raised floor. So actually, that's how the system capacity is going to be designed. But I will make different examples just to support you to how to do it. I will go back to that. We are not going to use any manifolds here, but we are going to use nozzles. Here, maybe you can find, actually, determining the size of the nozzle is up to the hydraulic calculation. However, we know the minimum and maximum discharge capacity of different type of nozzles. So I'm going to suggest you to check on the kilograms of this hazard and choose your nozzles accordingly. For example, you will require at least 1 piece of 1-inch nozzle for your ambient room. You will require 1 3/4 for the suspended ceiling, and you will require 1.5 inch for your raised floor at least. So depending on the architecture of your hazard, you might require 2, 3, 4 pieces of nozzles in different projects, in different capacities. So you need to always be on the safe side to decide about the quantity of nozzles. There are some optional products that you can use. For example, on the pipeline, you can always use a gas flow switch. So you can send a contact to the fire detection panel in case if system is discharging. And if you prefer to use the manometer with low pressure switch, you can also indicate here. It's a small reminder for you during your design. You can always add or delete these lines. We have the fire detection system. I'm sure you're also working with conventional detection system, so you can work on this part or you can totally neglect this part for your project. You can, as I say, add or defeat. So we can do 1, 2 more little calculations. We can make a little bit more bigger hazards like 10 meters to 8 meters. And we can use an ambient room for 4 meters, and we can use, no, let's say, okay, this is good. And we will have a raised floor like this, good. So in this case, the configurator already calculated. So we need to use more than 80 kilograms of gas. But if I would go to my cylinder range, I would find at most 180 liter cylinder. So in this case, I recommend, if you don't know about the architectural design of the hazard, or if you don't have the drawings, or if you cannot make hydraulic calculation at this stage, which we can't actually, it means you need to stay on the safe side. So I would recommend, for example, in this case, your system is really suitable to divide this gas quantity into different cylinders. You can always initiate the systems together and discharge the gas simultaneously. So you can go to this part that I try to explain, and you can choose your cylinder for the ambient room. Here you can choose 180 liters ambient room, and you will find the filling ratio here because you already have indicated your gas quantity required for the ambient. So you will always want to round up the filling ratio. You need to make a correction. When you make it, you will find out that the actual gas quantity you need to use is going to be 164 kilograms. So you also have a raised floor, and you require almost 22 kilograms of gas, but let's decide together. So you are going to use 27 liters of cylinder, and you're going to fill with 82%, and you're going to use 23 kilograms of HFC. So in total, you're going to use 187 kilograms of gas, actually, instead of this quantity. I hope it's a little bit more clear how to use the configurator. So again, here you can choose your nozzles. I'm sure in this case you're going to need 4 nozzles from 1¼ or it depends on how much risk you want to take, but maybe sometimes you can use like this, but it will be too risky. I wouldn't recommend, and I would recommend you to use at least two nozzles for the raised floor, like this, or you can also choose 1 inch. I mean, during your design preparation, you can always stay a little bit more on the safe side, but it depends on you. If you want to choose the exact quantities, you can be more precise. I'm just trying to explain. So we can do a little bit more examples. Maybe bigger hazards like 15 meter to 10 meter would be good, I think. 5 and yeah, okay. So here you can again find the ambient room capacity and the raised floor capacity. Always check the total gas quantity that you require, and if you can fill the gas quantity in your main system, don't separate the hazards. You can use here 2 pieces of 180 liter cylinders. You can always go back to the cylinder range, and you can choose 180 liter cylinders 2 times. So you can make a manifold battery system. It means you will have 2 times 180 liter cylinders, and each cylinder is going to be filled with 92%, which means you are going to actually fill your cylinders with 332 kilograms. So each cylinder is going to be filled with 166 kilograms of gas. So you can choose your nozzles accordingly with your ambient room kilogram capacity and raised floor kilogram capacity. We can do together. For the raised floor you can use, and for the ambient you can use. If you require me to continue with more hazards, or the examples, we can continue. Please lead me about this.
Okay, no, I think, thank you. I'll just tell you about the question Engineer Hussein raised. Is this the only way you are using to calculate the system needs and the calculations, or do you have any other software for calculation?
Yes, Azad, actually, we are. This is the how to say, this is the entrance of design. I mean, we are calculating. This is just to give a system quotation and determine the system capacity of the hazard. So once the system capacity is determined, then you need to make hydraulic calculation, and after the hydraulic calculation, you need to make the project drawing, and then of course the manufacturing and the filling. So there is a VDS approved software that is licensed to our company, which has the library that is consisting of our cylinder product range, our valves, and our nozzles. So when we enter any project info for the VDS software, then project by project, we receive the hydraulic calculation report on the system quantity, the system capacity, the cylinder selection, the nozzle selection, and the pipeline. That's the engineering part of this design.
I think this engineering process starts after submitting a quotation. I mean that we start here with a general overview and get the system needs. Yeah.
Yes. Then for example, when your customer is sending you a BOQ or an inquiry list with the names of hazards and hazard information and the sizes of the hazards, then you can use this configuration, or you can use, if you have other, I don't know, calculating tools from different manufacturers. I don't know until today how you were following up, but you can use this configurator, of course, anytime you want, and you can decide for which hazard, which system capacity you are going to use. And after you take the order, or after you give the order to us, we can start to make hydraulic calculation, because we need the AutoCAD drawings of the building and of the hazard that we will design. And we will also ask you to confirm the location of the cylinders. So job owner needs to confirm the project and the cylinder location, so we can use the hydraulic calculation software, and we can calculate the pipeline and the exact nozzles. I mean, this configurator is also okay to determine the nozzles, but we can determine the hole diameters of the nozzles because of the discharge time and etc. So hydraulic calculation is more for preparing the bill of material list of the system, of the product, and also preparing the discharge pipeline isometric and top view drawings. All these parts belong to after order. And actually, if you would like to do hydraulic calculation and the project drawing, it's a subject of another training, which will need much more time, and actually maybe after a little bit more orders, it can be more helpful.
Okay, good. I have other. I think as we're concluding, I'm just having some questions. I found it's clear at the beginning the technical submittal here that we have two configurations of pressure inside the cylinders, one 42 and the other is 50 bars. And in your configurator, you almost went back to the 42. When will we have to go the 50 bar configuration?
Can you repeat the last sentence? The connection was not good.
Okay. I mean when we will have to go to the 50 bar pressure cylinders.
Sorry. Yeah, sorry. So basically, you don't have to choose at the beginning. So we mostly do the designs under 42 bars. 42 bars pressure is really enough for designing and filling the cylinders. However, in case, for example, in this example, because we have at most 180 liter cylinder, and this cylinder can be filled at least 110% actually. So it means normally we can fill this cylinder to 185, 187 kilograms as well. However, if you receive the architectural design drawings of the hazard, and if this hazard is, for example, this hazard is 10 meter to 8 meter, if this hazard is like a square shape, if your pipeline is going to be really easy to discharge the gas, if it's not going to be really, I don't know how to say, not a lot of branches, so you are not going to lose the pressure of the gas for the discharge, it means that you can fill your cylinder maybe with 50 bars. So the nitrogen pressure can push the gas to the pipeline and to the fittings. But this is a decision that you can make during hydraulic calculation. You try with 42 bars first, and if you think you require more pressure because you have less place in the cylinder for your gas, then you can maybe choose 50 bars nitrogen pressure so that you can still use the same cylinder and try to push the gas more fast because the gas quantity is high. So it depends a little bit on the technical situation. And I recommend you to think of it if you have the architectural design or if the project owner gives you the hazard information in detail like this. For example, if there is a hazard information like 60 square meter and 4 meters of length, you know nothing. This 60 square meters can be, I don't know, 3 meters to 20 meters, a very long room, I don't know, or 15 to 4, or 6 to 5, sorry, 10 to 6. So the shape is always going to change, and you don't know exactly the shape actually in this stage. So you don't know how many fittings will be on the pipeline. You don't know how much pressure you will lose trying to discharge the gas, etc. And also sometimes, unfortunately, this happens to us a lot of times. We receive the project information like this, and then after order, the project info changes to this. It means we don't have only one hazard to protect, but we have two separations. It also means a branch on the pipeline, and every branch, every fittings connection means pressure drop on the discharge. So this is not a good scenario for us. If we don't know about the architectural final info during the quotation part, then we cannot decide on 42 bars or 50 bars. But it's not a matter actually. You can always keep on the safe side, as I explained to you, by rounding up and by using the cylinder selection, which can be filled. I mean, I don't know, maybe here it's a little bit risky, but you can always fill to 80%, 85%. It is good.
Okay. Yeah, okay. That was my next question regarding the filling factor, filling ratio to be 85 as maximum to be as safe. Okay.
I don't know, 85 to 90, but I would never recommend you to use a filling factor like 100% or
No.
95% if you don't know about the architecture, if you don't know exactly about the heights, because after the order, if the job owner wants to give you detail about the heights, and if there is an ambient room and also a raised floor, it means that you will need space in the cylinder for pressure to discharge the gas also to the secondary part. So I don't know if we had this discussion with you. When our customers are asking for a quotation from us, and when they send the hazard information only with a certain height, like let's say 4 meters, 5 meters, 6 meters, we always ask if there is any suspended ceiling or raised floor within the 6 meters or adding up to the 6 meters, because otherwise we need to change the design and we need to understand the gas capacity. So this is a really important detail when you try to determine the capacity of the system. I hope I'm explaining you clearly.
Yes, yes. Okay. My next question regarding, I found that at the beginning we have two types or two configurations of the actuators or the valves on the cylinder. One is the integration or completely integrated packaged actuator, electric actuator with the manual actuation, and the other one is just the valve, and you can insert the actuator. Yeah.
Yes.
Okay. What is the default we can get? I think by default we get the one integrated both in one. Yes, by default we get that in offers. Yeah.
In case if you need a VDS system approval, you always need to. We always quotate you this product because this valve has VDS approval, and the solenoid actuator and the manual actuator as well. So this product that is integrated with the electric actuator, this valve is not VDS approved. So this is also in our product range because this is a really cost-effective product. Cost-effective because the valve has the integrated actuator. But in case if you don't require any VDS approval, you can always use this alternative. It will create a cost effectiveness.
Okay. My last question regarding, I found that, just give me, the pressure gauges mentioned. I found, which is in page 18. We have different configuration with different pressure gauge with different range or scales. One for 060, 0100, 0100, 0100. I'm not sure what is the default one when we go with each one.
Okay.
What is the approach we are using to select? Yeah.
Okay. I understand. Thank you. So let's say you don't require any switch contact. Your customer is going to make eye control regarding the pressure of the cylinders, and they don't want your fire detection system to receive any signal from the pressure gauge or the pressure drop. This is possible. So in that case, you only have two alternatives. Here you can find first and the second pressure gauge. On the first alternative, you have the scale up to 60 bars. This scale can only be used for 42 bar systems. So if you are going to use a 50 bar system or if we are going to calculate the system for you, and in the hydraulic calculation part, we decide that we should fill this system with 50 bars instead of 42 bars, then we are going to use this manometer, which has the scale up to 100 bars. This is the difference between them. And regarding the switch contact pressure gauges, you can find two different pressure gauges. One of them, both of them has the scale between 0 to 100 bars. There is no difference, but there is a difference in the contact points. On the scale, this pressure gauge has a contact point here, you can see in red. This contact point is 38 bars. So the pressure gauge has the electrical cable, and this cable is going to go to the relay on the fire detection panel, conventional panel. On the there's an input for in our panels. There's an input which is controlling about the normally closed contact, and this contact is giving a label information which is called low pressure on the fire detection panel. So when the system is pressurized to 42 bars, in 10% pressure drop, it will drop to 38 bars. 10% is 38 bars. So the standards doesn't accept more than 10%. It means there is a problem, maybe there's a leak on the valve, or the system is discharging slowly by slowly. We don't know why. Maybe there's a problem. We need to check. It means that we have a contact point. If the cylinder is pressurized up to 50 bars, scale is the same, but the contact point is 45 bars, which is 10% of the 50 bars. And there's a problem if we go below 45 bars. It means we have a switch contact.
Okay, thank you. I just lost. It's not a question. Firstly, I need to thank you for this session. It's my pleasure, really, and it was informative. Thank you so much. And also, as usual, your collaboration. You're one of the impressive collaborator supplier or manufacturer. Just the last thing, I think you will share with us this Excel sheet, and hopefully, if you can share with me or with us a sample from any project you have already accomplished for the hydraulic calculation report.
Yes, sure. I will send you one example project from HFC Group. We have accomplished many projects in more than 20 years, so surely we will send you an example of hydraulic calculation, maybe from this year or last year, so you can get a recent one. And or I can send you maybe two or three different ones, so you can see. I will check for 42 bars and 50 bars. I will check for different alternatives so you can analyze. And also I'm going to send you this Excel configurator